We'll be looking at something different. We'll be looking at probability. Today, we'll be looking at what? Probability. Yesterday, we looked at statistics. So today, we'll be looking at something new, which is called what? Probability. Probability. Let's read the word. Probability. Okay. Alright, so we just do our students 1 minute to join the live section. Let's just give them 1 minute to join before we start. It's going to be an exciting topic. Probability is very important when it comes to JAMB Mathematics. It's very, very important. You need it, so you need to learn it. So when you see it in your exams, you will be able to answer questions. We'll also solve past questions today too on probability. Yes. We'll also solve past questions. Alright, so let's proceed. Let us proceed. So, what do you understand by probability? When you hear the word probability, what do you understand? Now, take down. Probability measures the stance of an event happening. So when an event is occurring, you use probability to know what is the stance of that event, how that event outcome will turn out. That's what probability is telling us now. So probability measures the will I use stance or should I use the outcome? I can use outcome or let's use stance. Okay, let's just use stance of an event. So this can also be seen as what? Outcome. So it's be able to tell us the outcome of an event happening. Now, there's a formula we use in probability. So let's write it down. Formula. And the formula for probability, P, is equals to the word number of favorable outcome all over the total possible outcome. All over the what? Total possible outcomes. So that's what the formula looks like, where P is what? Number of possible outcomes all over the total possible outcomes. Now, when we have 0, it simply means an impossible event. That's when our outcome is equal to 0. Then when our outcome is equal to 1, it simply means a what? Certain event. So you need to take note of all this I'm stating, because with the knowledge of this, you'll be able to what? Tackle any problem on probability. Very simple. Probability is equal to what? Number of favorable outcomes all over total possible outcomes. When we solve and we get 0, that means it's an impossible event. That means the event cannot happen. Then when our probability is equal to 1, that means it's certain that an outcome, something might happen, like something must happen. So let's solve some examples. Let's solve some examples. Let's solve some what? Examples. Now, example 1. Example 1. So a fair die is rolled. A fair die is rolled. You know what a die is? I'll draw it here. A die is that cube that has 1, 1, 1, 2, 3, 4, 5, and 6. It has 6 different faces. That's what a die is. Or some people call it dice. So a fair die is rolled, but the name is die. So this is what a die is. Something that has what? 6 faces. 6 different faces. So a fair die is rolled. They say we should find the probability of getting a 3. Find the what? Probability of what? We getting a what? 3. Now, what will our solution look like? Our solution, what will it look like? If the total die, okay, first of all, let's list out what a die has. So now, I will need this space to solve too. So, possible outcome from a die, we have 1, we have 2, we have 3, we have 4, we have 5, and we have 6. These are the possible outcomes that can show when you roll the die. 6 different outcomes. So we can say that our total outcome will be equals to what? 6 of them. Now, they now asked us that they told us that only one outcome out of these 6 will come out. Only one outcome. They say find the probability of we getting only one outcome, that's 3. If you throw it to only one outcome, which is 3, is equals to 1. Therefore, if we apply our formula, applying our formula, we know that probability is equals to what? Number of possible outcomes, which is 3, and 3 can appear only once because it has only one possible outcome for 3, all over what? The total outcome, which is what? 6. So you can write it like this, so you know P. So this is what is going to be our probability. Hope you're following. If you have any question, you can drop it in the comment section and I'll respond to that immediately. Yash Vera says all the best. Nora Veronica says good evening, sir. Alright. Beautiful. If you have any question, you can drop it in the comment section. So let's proceed. Please, if you're new to this channel, please don't forget to smash the like button. Don't forget to smash the like button. And don't forget to subscribe, please. Let's proceed. Example 2. Let's proceed to example 2. Example 2 says a bag contains 3 red balls and 2 blue balls. So a bag contains 3 red balls and what? 2 blue balls. Now they say we should find the probability of picking a red ball. To find the probability of picking a red ball. So now what will our solution look like? Solution. First of all, let's create space for ourselves. So first of all, we will get the total number of balls. We have started solving the solution. Total balls. So from the question, we have 3 red balls and 2 blue balls. So it will be what? 3 balls plus what? 2 balls, which will give us 5 balls. Now, step 2. What will be our favorable outcome? They said we should find the total number, we should find the probability of picking a red ball. So our focus is on the red balls. Our focus is on the what? Red balls. So now, the red balls has how many? 3 possible outcomes. 3 red balls. So we will write our favorable outcome. Our favorable outcome will be equals to red balls, because we are focusing on red balls. So focus on the red balls, which is equals to 3 possible outcomes. Next up, we apply the formula. So if we apply the formula, we have that probability of red balls will be equals to the favorable outcome, which is 3, all over the total number of balls, which is what? 5. So this will be our probability, because if we have 3 and 2 balls, that's total inside the bag, we have 5 balls. So if we are to pick one red ball, or we put our hand inside the bag, we can pick one of those 3 red balls out of the 5. So the probability will be what? 3 over what? 5. Please, I hope you are following. Please, I hope you are following. Because we'll be moving on to the next subtopic, which is called events. If you have any question, please let me know in the comment section. Don't forget to smash the like button. Let's go, let's go. The next topic, the next subtopic, sorry. The next subtopic is saying what? Events. Events. And for events, we have 2 types of events. We have the dependent event and the independent event. So we have 2 types, the independent event now. Take note, one does not affect the other. One of them does not affect the what? Other. Example, when you are tossing a coin, if you are tossing a coin can either be head or tail. So if you toss it, you can either get probability of head, or let's just draw the coin. This is our coin. And at the face of the coin, this is, let's say, head. And if you throw another coin, we draw it fine. Let's be fine. You can get towards tail. Now, this, if you get head or tail, now if you say the probability of getting H and what? T is equals to what? The probability of H times what? The probability of T. So this is an example of tossing a coin twice. Example of tossing. What is tossing? That's throwing a coin twice. So imagine now you throw a coin 2 times. If you get head at the first time, if you throw it the second time, you can still get head again, or you get tail. Or if you throw it the first time, you can get tail. So take note that one event, that's the first throw, the first tossing of the coin, does not affect one event does not affect the other. Are you there with me? Alright. Now let's solve an example, or let's talk about each of them, dependent and independent variable. Please, if you got this explanation clearly, let me know in the comment section. Just type I understand before I proceed. Just type it in the comment section. Let me recap. I said if you throw a coin twice, if you throw the first one, that's one event. And in that first event, you can either get head or tail. And anything you get from the first outcome will not affect the second outcome. If you throw the second outcome, or you throw the coin second time, you can also get head or tail. That's what I mean by all these things I wrote on the board. So let's proceed now. Now, for dependent events, what do you understand, or what do you understand by dependent events? For this one event affects the other. Take note of one event affects the other. That's if there's another event, it will affect it. So let's say example. For example, picking balls from a basket without replacement. A basket, or let's say a basin, anyone you want to use, without what? Replacing it. Now I'll draw it so you understand better. Now I have a basin here, and we have three balls, 1, 2, 3. If I pick one ball, okay, this is 1, this is 2, and this is all 3. If I pick one ball and keep it outside 1, how many balls now will be left in the basin? We'll be left with just 2 balls. So if they say I should pick another ball, the event has changed, because the first event we had 3 balls, but the second event now we have just what? 2 balls, because I did not replace the what? 1. So that's what we mean by dependent event. One event affects the other. Now let's look at independent events. Let's solve an example on independent event. We are done with dependent event. Let's solve an example on independent event. Independent event. We said a coin is tossed twice. Let's use a coin. A coin is was tossed twice. Now, so if you find the probability of getting head and head, that you want to get head 2 times, find, you know what head is, right? The probability of getting head and head, that's heads, head and what's head. Alright, so what will our solution look like? Our solution will be probability of H is equals to what? Number of favorable outcomes all over what? Total outcome. Now, for this, our total outcome will be equals to what? Head and what? Tail, which is equals to 2. Now, they say we toss the coin twice. So if we toss the coin the first time, our number of favorable outcome to get head will be what? 1. So therefore our probability of getting head will be what? 1 over 2. But now take note, we are talking about independent event. For dependent event, they say there is no replacement. But for independent event, the second throw of the toss or of the dice will not, or the coin, sorry, the second throw of the coin will not affect the event. So if we want to throw the coin again, we still have total outcome to be what? 2. And then I said we should find the probability of getting head and head. So this is probability 1. So now for the second one, we are still trying to get head. Our number of favorable outcome will still be 1 over the total outcome will be what? 2. So now we've tossed these dice, we've tossed this coin 2 times. This is the first toss, this is the second toss. Now they say we should find the probability of getting head and head. Therefore, the probability of getting head and head will be equals to the first toss times the second toss, which will be what? 1 over 4. So this is an example under independent events. Please, if you understood what I just explained now, let me know in the comment section. Oluwaran Bello said 2 balls. Correct. You have 2 balls. Okay, that was from the previous example. This one I'm talking about head. 2 heads, not balls. Okay, Wally Tony said, I understand. Alright, so we can proceed. Thank you very much for that feedback. Alright, let's proceed. Now, let's solve one example on dependent events. Let's solve one example on dependent events. We are done with independent events. Now, let's solve on dependent events. A bag contains 4 red and 3 blue balls. A bag contains 4 red and 3 blue balls. Okay. It says 2 balls are picked without replacements. Now the question goes like this. Find probability that both are what? Red. Find the probability that both are red. So what would our solution look like? Now take note of this. We are picking it how many times? 2 times. So we'll have probability 1 and we'll have probability 2. That's the first thing you should take note of. Secondly, we are picking without replacement. So probability 2, the total outcome will be less than probability 1. Now we have 6 balls, right? 1, 2, 3, 4, 5, 6. Okay, 7. 4 plus 3, 7. 6, 7. And they say that 7 of them are inside a bag. They are inside a bag. Okay, let me draw my bag. How my bag look like? Let me not use basket. Let me draw a bag. Okay, this is school bag. So it should be like this with pockets. Okay, and handles. Alright, so it's inside this bag. So if you take out one ball, let's just say we pick at random, or let me arrange it. Let me not use numbers, let me use colors. Let me use colors so you understand the logic here. We say red and blue, right? So let's use arrow for red. Arrow, arrow, arrow. That's we have 4 red. That's 4 arrow. Then we have blue, B, B, and B. 4 red and 3 blues. So for the first probability, our total outcome will be equal to 7. And since you are focusing on red balls, our total red ball will be equal to what? 1, 2, 3, 4. So P1 for red balls will be what? 4 over 7. This one is for what? Our first probability. Now, they said if we take another ball, so now we have collected one red ball. Let's clean it. We have collected one red ball, so let's clean out the red ball because they say without replacement. So we are cleaning out one red ball. So now let's count how many balls now are inside this bag. 1, 2, 3, 4, 5, 6. So now the total, so let me write it here. The total what? Outcome is now equal to what? 6. Now how many red balls now do we have in this bag? It was 4 before now, but now let's count. 1, 2, 3. So red balls will be equal to what? 3. This is what? For the second probability. Remember they said for dependent event you take out balls without replacement. So when you take out a ball from this bag, it will affect both the total and affect the red ball. So now our probability, the second one, for red ball, if you are targeting red ball, it will now be what? 3 over 6. If you divide it further, you will have what? 1 over 2. Are you following? Now, we have gotten the probability of 1 and probability of 2. So now our probability of 2 red balls, are you watching? Please watch. Our probability of both, that both should be red, like what they asked in the question, probability of both are red, will be what? P1 times P2 will be equal to what? P1 times P2, which is equal to what? 4 over 7 times 1/2, which is equal to what? 4/14. Are you seeing it? This is going to be our what? Probability. Very, very simple. Please let me know if you understand what I just explained now in the comment section before I proceed. Please let me know. Please let me know. Very important. Your feedback is very important. Please let me know so I can proceed. Hello sir, it says 2 balls are picked without replacement. So how do we arrive at 6 balls? Alright, Oluwaranti Bello said, he says 2 balls are picked without replacement. Now, let me explain. They said 2 balls are picked. For the first event, you pick 1 ball. If I'm to pick 2 balls from a bag, before I pick the second one, I'll first of all put my hand inside the bag. Now look, watch, we had 4 red balls and 3 blue balls, which is making it a total number of 7 and 4 red balls. So now, imagine I dip my hand inside this bag. I want to collect 2 balls. They say we should collect 2 balls, right? So I dip my hand inside this bag. I carry this bag, this ball, and I drop it outside here. 1. So this ball is no more here. The ball is no more here. I've taken out 1. They say we should take 2. I've taken out 1. Now, if I put my hand inside again to collect the second one, while I'm collecting the second one, while my hand is inside, what is remaining is just 6. And how many red is remaining is just 3. That's why it's dropped. So we are following the process of the event. We are doing it one after the other. We are not putting our hand to collect 2 at once. We are collecting it one by one. 1 first out. We will now collect the second one. If we collect the second one now and we keep it outside, another red ball, we have gotten what? 2 red balls. So we'll stop. We'll stop. So now we have how many balls remaining in the bag? We have 5 balls. 2 are red and 3 are blue. If they say we should make another one again, we'll pick again. When we want to pick, this value will still drop again. So that's why. Do you understand this explanation? Alright, did you get the explanation? If you got it, then we can proceed. We can proceed. If you got the explanation, we can proceed. Okay, let's move on. Let's move on. We are done with these events. Let's look at something else. Now, let's look at some calculations in probability. Some calculations in what? Probability. Let's look at the first rule. We have or. Whenever we see or in probability, what does it mean? Or, which is a rule, it simply means addition rule. It is used when events can happen separately. Please take note. When we have events happening separately, we use or. So let's write is used when events can happen separately. Please write this down. So we have that the probability of two events A or B is equal to what? The probability that happened in event A plus the probability that happened at event B. But take note, if events cannot happen together, that's mutually exclusive, okay, let's put this, this is not the formula, this is the complete one now. Equals to what? P N. They are happening together. They are happening what? Together. This sign now, we said, is an intercept that's together. But if the event cannot happen together, that's mutually exclusive. This is the first condition, this is the first formula. Now, this same or has another formula. They said if events cannot happen together, now we say they are what? Mutually exclusive. They are what? Mutually exclusive. This is U before A. Sorry. Now for that one, the formula for or will be probability of the first event or the probability of the second event is equal to what? Probability of the first event plus probability of the second event. So you can use this first one when the events can happen separately. While you use this one when the event cannot happen together, that's exclusive. This one is an intercept between the two events. So let's look at the second rule. This is our first rule. Let's look at the second rule. Now for the second rule, it's called what? Component rule. Component rule. For the component rule, we have P into the component of the first event is equal to what? 1 minus the probability of the first event. This is the formula. So let's take an example. Let's take an example. The example we'll take now will be on the first rule. The first rule, example 1, the OR rule. Please write this down. We'll be increasing our speed. A die is what? Rolled. Find probability of getting a 2 or 5. A 2 or 5. So if we roll a dice, what's the probability of we getting a 2 or 5? So our solution will be, now we know that the total outcome from rolling a dice will be equal to 6 different outcomes. We can have 6 different faces from our die. This is our die. We have 6 faces: 1, 2, 3, 4, 5, and what? 6. Any of the face, when we roll the die, we have 6 different outcomes. And now they say we should find the probability of we getting either a 5 or a 2. So now, the favorable outcomes which is 2 or 5 is what equals to what? 2. So we can get 2 as our favorable outcome. We can get 2 outcomes. Either we get 2 or we get 5. So we have 2 outcomes. So now, if we apply the probability formula of getting 2 or 5, it will now be equals to what? 2, that's this one, that's favorable outcome, over 6, which is equals to 1 over 3. Very simple, very, very simple. Since you are rolling the dice, once you roll it, you can either get 2 or 5. That's 2 outcomes. The total number on the die is 6, so it will be what? 2 over 6. So let's proceed. We'll be moving on with speed. We're moving on with speed now. Now, let's solve an example on component rule. Example 2, component rule. So for component rule, you said a what? Card is drawn from a standard block. Is drawn from a standard block. And inside that standard block, we have what? 52 cards. We have 52 cards. So they say a card is drawn from a standard block. Find the probability of not getting a king. Find the probability of not getting a king. Now, this one is focusing on not getting a king. Let's use this not in bold. Not. The other one was or. This one is not getting a king. So is a what? Okay, not complement, complement, sorry. Complement rule, not component. Complements. Complement rule, sorry. Complements. Alright, let's proceed to our solution. So our solution will be, now in a card we have 52 cards. So number of cards, total number of cards. Total number of cards will be equal to 52. And inside that card, the total number of kings is equal to what? 4. We can have just 4 different kings. Now let's proceed. So now the probability of us getting a king, is going to be equal to what? 4 over 54. And if we divide 4 over 54, we'll have what? 1 over 13. This is the probability of us getting a king. This is the first part of the equation. Now, they now said find the probability of not getting a king. But this one is the probability of getting a king. So if we don't want to get a king, we need to use the what? The formula for what? Complement rule. And that formula has probability of not getting a king will be equal to what? 1 minus what? The probability of a king. That's 1 over 13. And if you solve this, we'll have that the probability of not getting a king will be equal to what? 12 over 13. Very, very simple. Very, very what? Simple. So we have touched everything we need to touch on probability. We'll be moving on to the next topic, which is what? The next subtopic, which is permutation and combination. Permutation and combination. So please, if you understood this part, let me know in the comment section that you understood this part so we can proceed. Let me know that you're understanding what I'm saying so we can proceed. So we're looking at what? Permutation and combination. We are done with calculations on probability. Let's look at something else. Alright. We are looking at what? Permutation and combination. Now, what do we understand by permutation and combination? Now, the both of them, take notes, write this down. The both of them are used for counting, arrangement, and selections. So they are both used for counting, arrangements, and selection. So if you are giving a group of persons to select one or two persons from that group, you will use that permutation or combination. Or if you are counting, you use that permutation or what? Combination. Now, for the first one, permutation, arrangement is priority. So arrangement matters a lot. This matters a lot. And there's a formula for this. For permutation, the formula is equals to what? N factorial all over n minus r factorial. Very, 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 very important. Where n is the total number of total group, then r is the total number they ask you to count or select. N is the what? Total number of persons or group, while r is the one they ask you to what? Count. Take note, it is used when order matters. It is what? Used when order matters. So as far as it's orderly, is an orderly manner or is in arrangement, you use permutation. But if it's at random, you cannot use what? Permutation. So now let's look at combination. Let's look at combination. Combination. For combination, For combination, order does not matter. You need to know this. And the formula for combination is this: n factorial all over r factorial into what? N minus r factorial. So this is the formula for what? Combination. And like they said, it is used only when order matters. It is used when order does not matter. So now let's solve examples on each of them. Let's solve examples on each of them. But before we solve examples on each of them, let me show you what this factorial means. This symbol, factorial, what does it mean? I want to show you now before we start solving examples. Now, if we're given, okay, we're talking about factorial. If we're given n factorial, it simply means n times n minus 1 times n minus 2 and so on. We keep going. For example, let's say we have our n as 5 factorial. So 5 factorial would simply be 5 times 4 times 3 times 2 times 1. If we have 4 factorial, it will be what? 4 times 3 times 2 times 1. If we have 3 factorial, it will be what? 3 times 2 times 1. If we have 2 factorial, it will be what? 2 times 1. Now, this 5 factorial can also be what? 5 times what? 4 factorial. Because 4 factorial is what? 4 times 3 times 2 times 1. So it can be 5 times what? 4 factorial. Are you seeing it? 5 times 4 factorial. Now, 4 factorial can be what? 4 times 3 factorial. Because 3 factorial now is 3 times 2 times 1. That means 4 times what? 3 factorial. Similarly, if we have 3 factorial, it's the same thing as what? 3 times 2 factorial. And we know that 2 factorial is 2 times 1, which is this. So it will be 3 times 2 factorial, which is 2 times 1. And we have others like that. So in case I write 5 times 4 factorial, you should understand what I mean. If you see me write 4 factorial as 4 times 3 factorial, you should understand what I mean. Because we'll be using it to solve as we are going on. We'll be using it to solve. Alright, let's take example 1 on permutation. Example 1 on what? Permutation. Now example 1 says, how many ways can 3 students be arranged from 5 students? Now this example 1 is an example under permutation, so let's just think this combination. How many ways can 3 students be arranged from 5 students? So now what will our solution look like? Now we have the total number of students, the total number of students, let me write this. Our total number of students, which is n, is equals to what? 5. Our total number of students represents n and is equals to what? 5. And they're asking us, how many ways can we arrange 3 students from these 5 students? Now we have 5 students. 1, 2, 3, 4, 5. So now how many ways can we arrange them? We can arrange them like this 1, 2, 3. We can arrange them like this 1, 2, 3. We can arrange them like this 1, 2, 3. So how many ways, how many different ways can we arrange them? So now our arrow will be equals to what? 3 students. Our arrow will be equals to 3 students. Now from permutation formula, we know that permutation is equals to what? N factorial all over what? N minus arrow factorial. So this is our formula for what? Permutation. So we can now write that what? We'll substitute in our n as 5. So it will be what? 5 permutation 3 will be equals to what? N is 5 factorial equals to 5 factorial over 3 over what? Sorry. Over 5 minus 3. N is 5. Arrow is what? 3. Over what? 5 minus 3 all in factorial. So this is what our solution will look like. So if we break it down, we will now have what? 5 factorial all over 5 minus 3 is what? 2 what? Factorial. Now, if we expand this 5 factorial over 2 factorial, we will have it as what? 5 times 4 times 3 times 2 times 1 all over 2 times 1. This is one way. We can also arrange it like this: 5 times 4 times 3 times 2 factorial all over 2 factorial. Take note, 2 factorial is what? 2 times 1. 2 factorial is 2 times 1. So we can cancel that 2 times 1. We can cancel that 2 factorial. I see it. So we left with what? 5 times 4 times 3. 5 times 4 is 20. 20 times 3 is what? 60. So our final answer will be equals to 5p3 will be equals to what? 60. Which is 5 times 4 times 3. So this is going to be our final answer for this example. Very simple. Let's proceed. Now let's solve a question on permutation. Let's solve another question on what? Permutation. Let's solve another example. Now this example, example 2, will be on combination. This example is going to be on what? Combination. Now, example. The example says, how many ways can you select 2 students from 5? The same question, but the same pattern of question, but this time we are going to use what? Combination. If you take note of the first question, they said, how many ways can 3 students be arranged from 5 students? That word arrange simply tells us that it is orderly. That's why we use permutation. Take note. But this example now, they did not say anything like arrange. They just said how many ways can you select 2 students from 5? Straight to the point. How many ways can you what? Select 2 students from 5. So now our solution, we know that the total number of students will be equal to what? 5. And we have just 2 students, so our arrow will be what? 2 to select from the 5. Now, for combination, the formula is n combination arrow is equal to what? N factorial all over what? Arrow factorial into what? N minus arrow factorial. Please take note of this formula. Very, very important formula. Very important. Please, if you are following me to this point, let me know in the comment section. Chat me up, write it in the comment section. I am following. Let me know if you are following up. Let me know in the comment section. Don't forget to smash the like button. Please don't forget to smash the like button as you're watching. Alright, Wale said, Tony said, I understand. So let's proceed. In case you're new to this channel, please make sure you help us to subscribe to the channel. Alright, let's proceed. So now we'll simply will substitute in our value. Or let's just get our factorials out first. 5 factorial, like I said, is what? 5 times 4 times 3 times 2 times 1. And we have what? 2 factorial as 2 times what? 1. Alright. So now if we substitute in our value, we have that 5 combination 2. Why we use combination, please take note. This is not arranged. It doesn't say how many ways can we pick 2 students. So we can pick them any way, not in arranged format. So now it's not equal to what? 5 factorial all over what? 2 factorial into 5 minus 2 factorial. So we will now have what? 5 factorial all over 2 factorial into 5 minus 2 is what? That's what? 3 factorial. Now, we know that 3 factorial is equal to what? 3 times 2 times 1. So, if we have 3 factorial as 3 times 2 times 1, and we have 5 factorial as this, so we can simply write it as what? 5 times what? 4 times 3 factorial all over 2 factorial times what? 3 factorial. Now, why we did it like this so we can cancel out? Because 3 factorial is 3 times 2 times 1, and we have 3 times 2 times 1 inside 5 factorial, which is this. So you can say 5 factorial is 5 times 4 times 3 factorial, which is the same thing. So 3 factorial will cancel out 3 factorial. So we'll be left with, okay, let me write it here. We'll be left with what? 5 times 4 all over 2 factorial is 2 times 1, which is what? 2. It will now be what? 20 over 2. 22 will cancel here to get 1. 2 will cancel here to get 10. And our final answer will be what? 10. Very, very simple. Very, very simple. So we are done with combination we are done with what? Permutation. So in case you see a question on combination, you should be able to what? Tackle that question. And in case you see a question on what? Combination, we will be able to what? Also what? Tackle that question. So thank you for joining our class. This is the end of today's section on probability. So in case you're not on our WhatsApp group, you can join our WhatsApp group, or if you have any question, you can text me on this WhatsApp number. Let me write the WhatsApp number. Let me write it here. 081-263-88049. You can text me on this WhatsApp number. But if you are not in the country, you can remove the 0 and put +234. This is Nigeria country code. This is my WhatsApp number. Feel free to ask me any question you have on JAMB. Any question you have on JAMB. I remain my humble self, Calabo Beke Divine. And this class was organized in collaboration with the JAMB Master. The what? JAMB Master. The JAMB Master. You can also set up his YouTube channel and subscribe to his own channel too, the JAMB Master. Yes. So this is the combination of what? The JAMB Master and Build and Design Academy. Yes. So please, you can chat me up for any problem you have on your mathematics. And if you want to join our group, you can also chat me up, or you chat up the JAMB Master, so you add me up to the WhatsApp platform. Thank you for staying to the end of this class. We had an exciting week because we started from Monday. We moved from Monday to Tuesday. From algebra, we moved to mensuration. We moved to trigonometry. We moved to calculus. We moved to statistics, and today we are in probability. It was an exciting journey. In case you missed the previous classes, you can watch our replay on live. Yes, watch our replay. Make sure you follow it up and prepare. The next thing we'll be tackling will be past questions. So we'll drop the information on the WhatsApp group. See you in our next section. Bye.